So in this video, I'm going to be teaching you how to use bitwise operators in JavaScript. But let's start with some basics. When we use numbers on a day-to-day basis, we use what's called the base 10 number system. This is also referred to as the decimal number system. This number system contains 0 up to 9, and all other numbers we use are created using those digits. Computers do not use the base 10 number system. Instead, they use what's called the binary number system, which is sometimes referred to as base 2. In the binary number system, all numbers are created using only 0 and or 1. On the screen, you can see how the decimal and binary number systems compare. So each digit in binary is called a bit. In computing, a byte is 8 bits. Numbers in JavaScript are stored as 64 bits. The number 1 from the base 10 number system, represented as 64 bits, is now shown on the screen. As a side note, that example is not the following because in JavaScript we use what's called the double precision format. As 32-bit, this would be represented as so. When we use bitwise operations in JavaScript, it's worth understanding that the operations are not directly done on the 64-bit value. JavaScript converts the value to 32 bits to perform the operation, and then the value is converted back to the 64-bit representation. So now we have a foundational understanding, we can move on to looking at the bitwise operators in JavaScript. These are as follows: AND, OR, XOR, NOT, zero fill left shift, signed right shift, and zero fill right shift. Let's start by looking at the bitwise AND operator. The bitwise AND operator is represented with the ampersand symbol, and it's used on two values. The return value is either 0 or 1. The two values are lined up together and each set of values are compared. If both of the bits are 1, then the return value for that bit will be 1, otherwise it will be 0. Let's look at an example to clarify this. I'm going to start by declaring a variable called val1, and I'll initialize this with the value 8. Next, I'll go ahead and declare another variable called val2, and I'll initialize this with 9. For reference, on the screen I have listed 32-bit representation of these values. Now, in a console log, we'll use the bitwise AND operator on these two variables. The return value is 8. Let's break down this result. In both the variables, everything but the last 4 bits are 0, so until this point 0 will be returned for each pair, as is shown on the screen. At this point, the next pair of bits to be compared both contain 1, so 1 will be returned. The last 3 pairs will be compared in turn, but no pair contains 2 sets of bits with 1s. We get 0 and 0, then we get 0 and 0, and lastly we get 0 and 1. Therefore, for each of these pairs, a 0 will be returned. This gives us our final result in 32-bit representation. When this is converted back to decimal notation, for us to understand, we get the value 8. The bitwise OR operator works on two values in the same way as the AND operator. We use the pipe symbol for the OR operator. This time though, if both bits are 0, then the return bit will be 0, otherwise the return bit will always be 1. Let's look at an example. We're going to use the val1 and val2 variables again. This time, in the console log, we're going to use the bitwise OR operator. We get 9 as the return value. Let's look at the comparison of the last 4 bits of the variables. Until this point, every bit is 0. This means the OR operator will return 0 for each comparison. At this point, we get 2 bits of 1 compared. The OR operator will return 1 if both bits are not 0, so 1 is returned. The next 2 comparisons both compare bits of 0. The OR operator returns 0 for these. Lastly, we get 0 and 1, therefore 1 will be returned. The bitwise XOR operator is represented by the cat symbol. This operator again compares 2 bits. If only one of the bits is 1, then the result will be 1, otherwise it will be 0. So let's look at an example. We'll use our val1 and val2 variables again, but in the console log we'll use the XOR operator. We get 1 as the return value. The only time we get a set of bits with different bits is the last pair. In the last pair we compare a 0 and a 1. This means this is the only time 1 is returned. Therefore, the return value is 1. So now let's look at the bitwise NOT operator. This operator is represented by the tilde symbol. If the bit is 1, then 0 will be returned. Otherwise, 1 will be returned. So let's look at an example. We'll use the val1 variable and console log this out using the NOT operator. The zero fill left shift operator is often just referred to as left shift, and it's represented by 2 less than symbols. This operator will shift all the bits to the left to the amount of the number used. Let's look at an example. We'll use the val1 variable again, and then in the console log, we'll use the left shift operator with 3. We can see all the bits get moved along to the left by 3, and everything in their original places is filled with 0. The zero fill right shift operator is often just referred to as right shift or unsigned right shift, and it's represented by 3 greater than symbols. The operator will shift all the bits to the right to the amount of the number used. So we'll use our val1 variable, and this time in the console log, we'll use the right shift operator with 3. We can see that all the bits gets moved along to the right by 3, and everything in their original places gets filled with 0. So the last operator to look at is the signed right shift. The signed right shift is represented by 2 greater than symbols. The operator will shift all the bits to the right to the amount of the number used, but it will preserve the sign, so positive or negative, of the value. The first bit of the 32-bit representation indicates whether a value is positive or negative. So let's look at an example of this operator. This time we'll create a new variable called 𝑟Example, and we'll set this value to -9. Now, in the console log, we'll use the signed right shift operator with our variable. We get -2 returned. All the bits get moved along to the right by 3, and everything in their original places get filled with 0. This gives us -2 as the return value. If we had used the unsigned right shift operator here, we would have got the following result. I hope you enjoyed this video. Please like and subscribe for more content.